All right, we're on section 5.5, completing the square. We've been working on that a little bit, excuse me, this week. I'm going to get into specifically completing the square and then completing the square with a leading coefficient, or at least a portion of those problems. So let's go to work. Go ahead and share it. I'm going to do section 5.5. I'm going to do 6 problems here. I'm going to do 6 of the odd problems. Your homework will be the even problems from this section. That way you can do those and then use the even homework or even work problems videos that are on your Algebra 1 curriculum timeline to kind of check yourself and make yourself sure you're doing it correctly. Yes.
Send AJ to the office, please.
On his way. All righty, that'll be there forever for everybody to enjoy. Okay, so let's look at number 1. Number 1's normal. It's what we've been working on. Okay, I'm going to complete the square. Okay, let's do that. So x squared minus 2x, leave myself a space, minus 8. Now, what am I going to fill in that space? Whatever is required to get me a perfect square trinomial. Well, I'm going to take the middle number, which in this case is a -2, divide it by 2, which is -1, and then I'm going to square it, which -1 squared is 1. So I'm going to add 1, and I'm going to subtract 1. What that did is cause this in the middle to be a perfect square trinomial, which I can factor, boom, like it's my job. Oh, wait a minute. Kind of is. X minus 1 quantity squared. And then I can combine these two at the end, which is a -9. Now that is in vertex form. For all I care, that's as far as I want to go. I want to know the vertex, which in this case would be 1, -9. Now, in these homeworks, it said find the vertex using any method, which is exactly what we want to do. Okay? Number 3. Again, no leading coefficient. I'm going to work a little faster on this one and number 7 because, well, actually not this one, because I look up there and I see an odd number, and this may be the first time you've seen one of these, so please pay close attention. So we got f of x equals x squared minus 5x, leave my space, plus 4. Now stay with me here. What is 5 divided by 2? Well, it's 2.5, but I don't like that fraction, or that decimal. I like the fractions better. What would I do with that? Well, then I would square it, yes? So let me just go ahead and square it as a fraction. 5 squared is 25. 2 squared is 4. Oh, should see the looks on these faces. Okay, so guess what I'm going to add and subtract? 25 over 4. Oh, no. Oh, no. It's all right. Stay with me. Plus 25 over 4 minus 25 over 4. I still added absolutely nothing. This is a perfect square trinomial. I can still factor it. What do you mean you can still factor it? It becomes x minus what? 5 halves. 5 over 2. Not 25 over 4, but rather 5 over 2. Quantity squared. Now, I do have to put these two together, but 4 could be rewritten as 16 over 4. How many times does 4 go into 16? 4. So I could write 4 as 16 over 4, right? So now -25 plus 16 is a -9 fourths. What is my vertex then? 5 halves and a -9 fourths. I know. You guys are going, did I do anything different? No, it just has fractions in it. No big deal. I'm going to jump to number 7 and do it, and then I'll come back and do 5, 9, and 11. Why am I going to jump to number 7? Well, because it does not have a leading coefficient. So again, let's solve this by completing the square. So x squared minus 4x. Boy, there's a nice even number. We got to like that. Plus 8. Since it's even, it's going to be divided by 2, no problem. So negative 4 divided by 2 is 2. Well, it's a negative 2, but negative 2 squared is 4. So I'm going to add 4 and subtract 4. That's how you really do nothing right there. And then I factor that perfect square trinomial to get x minus 2. Quantity squared, combine my two constants out there, which is 4. What is my vertex? 2, 4. Okay, we like that one again. Yes? All right. So there, that's what we've been doing. No problem. Now, let's look at number 5. Number 5 is a little bit different. Why is it a little bit different? Because there's a leading coefficient. Okay? Anytime there's a leading coefficient, we want to pull that thing out before we complete the square. So please, I'm going to do 3 of these and that's it. So grab what you can. Okay? There's only going to be 2 of these in your homework. Okay? So anyhow, look for a GCF. Is there a GCF? Why, yes, I can pull out a 2. 2 times x squared minus 6x plus 3. Everybody okay with me pulling out that 2? No problem. So now on the inside, I want to complete the square. So I'm going to leave that place and plus 3. So I left that space. Is that good? All right. Now I just want to focus on the inside for a second. That 2 is going to sit out there, but I'm just going to focus on the inside. So let's complete the square like we normally would. Negative 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 and I'm going to subtract 9. Okay. Here is my perfect square trinomial, which I can factor. That 2 is just going to sit out here. Okay. 2 is just going to sit out here for now. Factor this perfect square trinomial to be x minus 3 quantity squared. And combine the 2 things on the outside. Negative 9 and a positive 3 is a negative 6. So far, so good. Now, notice that I put this set of bracket around the outside after I put that 2 in there, yes? Can I distribute this 2? Yeah, I can distribute that. So if I distribute it times the first thing, I'm just going to set it there. 2x minus 3 quantity squared. Then I also have to distribute it to the negative 6, right? And 2 times negative 6 is negative 12. This is my equation in vertex form. So what's the big picture? I had to pull out my leading coefficient, complete the square on the inside, and then I had to put that leading coefficient back in or distribute it back in. Okay? Because my vertex is 3, negative 12. It is not 3, negative 6. And that's where the difference is. Okay? Did I answer your question right there? Cool. All right, let's try another one. Let's go to number 9. Number 9 also has a leading coefficient. Okay? Since it has a leading coefficient, I'm going to try to pull that out. Can I? Yes. So 3 times x squared plus 3x plus 1. I went ahead and put that space in there because I'm going to complete the square. Cool? Oh, no. There's an odd number. Yay. I know you're not going to like it, but it'll be okay. Okay? Because 3 divided by 2, it doesn't go in evenly, does it? So I'm not going to turn it into a decimal. I'm just going to square it. So 3 squared is 9. 2 squared is 4. So I'm going to add 9 fourths, subtract 9 fourths. This is still a perfect square trinomial right there. So bring down that 3 and then factor this perfect square trinomial, which is x plus 3 halves quantity squared. And now I have to add these 2 like terms. Well, on the end, those like terms, they got to have a common denominator before I can add them, right? So what would my common denominator be? 4. So let's change that 1 to be 4/4. Is that cool? Sure. Negative 9/4 plus 4/4 is a negative 5/4. Almost done. Because there was a leading coefficient, I had to pull out that 3. So now what? I got to put it back in. I'm going to multiply it here and there. Okay? So 3 times x plus 3/2 quantity squared. And then when you multiply fractions, all you do is multiply. So 3 times 5 is a negative 15/4. Can I get a whoop whoop? So what's my vertex? Negative 3/2 and negative 15/4. That would be really terrible to have to graph, wouldn't it? But it could be done. All right, I'm going to do one more. Hopefully it won't be quite so hairy. But looks like it's going to be. All right, what's the first thing I do? Pull out my GCF. Okay, so 3 times x squared plus 3x plus 2. Let me leave that space. Plus 2. Okay, so 3 divided by 2 squared is 9/4 again. So plus 9/4 minus 9/4. There's a perfect square trinomial. Factor it. X plus 3/2 quantity squared. And then I could rewrite 2 as 8/4, right? So minus 1/4. Distribute the 3 back in. So I get 3 times x plus 3/2 quantity squared minus 3/4. What is my vertex? 3/2. Sorry, negative 3/2 and a negative 3/4. Cool? All right, so if there's a leading coefficient, pull it out, complete the square on the inside, distribute it back in. Can you handle it? Homework. 2 through 18 even. Have a great day.